Java 3D Cube Runner. Part 1. Small cube running through scattered cubes. This video explains how to create a base on which cubes are randomly scattered, and a smaller, automatically moving cube that can be steered left and right. In the following videos in this series, I will explain how to display the message, "Game over," when the moving cube collides with one of the scattered cubes, or the cube falls off the base, and how to display the message in the center of the game window, even if the scene is moved by pressing an arrow key. I will also explain how to display the elapsed time in the game window, and when the moving cube reaches the far end of the base, how to display the message, "Goal." Additionally, I will explain how to accelerate, speed up, the moving cube, and how to stop the cube at the far end of the base when it reaches the end, the goal, despite the changing speed of the cube. Don't miss it! This video consists of 3 parts. 1. How to create a base which is wider and thinner than that created in the video. Java 3D Cube Slide Game Part 1. Shooting a projectile. For details, check out the video. 2. How to create randomly scattered cubes, which has also already been explained in a previous video. Simple Java 3D code using shared group. Let's change expressions used as arguments. For details, check out the video. 3. How to create an automatically moving cube, which we can rotate to the right and to the left using keyboard keys. Using a subclass of the behavior class allows us to move the cube constantly each time the moving color cube object is awakened. The process stimulus method is executed, and the cube acts as specified in the method. Using the key-typed method allows us to rotate the cube as specified in the method. Source code explanation. Source code links in description. Feel free to use the source code to make your own Java 3D program. Creating a base. 1. Create TG. Move it by -15.0 so that we can see the base from a little bit above. Create shared. Connect a color cube to it. Create TG link. Pass shared to a link object and connect it to TG link. Connect TG link to TG. In the inner loop, Z changes in increments of 6.0 from -440.0 to -50.0. In the outer loop, X changes in increments of 6.0 from -180.0 to 180.0. The X and Z positions of TG link change accordingly. A cube with a side length of 2.0 is created, and the cube is scaled up to 3 times, so the size of each color cube is 6.0. Therefore, each end of the base is 3 larger. This is important for determining where the moving cube drops and where it reaches the goal. TG link is rotated around the z-axis by -1.57 radians, -90 degrees. 2. Creating a randomly scattered cubes. 3. I specified the inner loop and outer loop as follows. You can change these numbers as you like, as long as the cubes are on the base and properly scattered. For example, if you change the increment from 50 to 70, the cubes become more sparsely scattered. Make sure that the value of x does not become 0. If x equals 0.0, whatever you multiply by x, 0.0, is always 0.0. So the color cubes are aligned in a straight line. Since Math.random generates a random number greater or equal to 0.0 and less than 1.0, when x is minus 180.0, minus 180.0 multiplied by Math.random generates a number in this range. When x is minus 130.0, minus 130.0 multiplied by Math.random generates a number in this range. The same applies to other x values as well. With this method, the values of x are concentrated closer to the center. It's a game, so it's okay because it becomes more difficult to pass through the middle. Suppose we specify the line for the inner loop like this. When z is minus 440.0, minus 440.0 multiplied by Math.random generates a number in this range. There is a possibility that z multiplied by Math.random will be before minus 50.0. When z is minus 420.0, minus 420.0 multiplied by Math.random generates a number in this range. There is a possibility that z multiplied by Math.random will be before minus 50.0. This happens to other z values as well. Therefore, I moved z multiplied by Math.random in the negative z direction, minus 100.0, not just minus 50.0, but minus 100.0. Then, I adjusted the z position here. The z position in the inner loop needs to be changed from minus 340.0 to 20.0. As the result, there is proper space here. And randomly scattered cubes do not extend beyond the back edge of the base. 4. Creating a moving cube. 5. Create a moving color cube object, C-cube. Connect TG in C-cube to TG. Connect C-cube to TG. 6. 7. Tell Java 3D you are going to move TG at runtime. The true meaning of 0. If wake up on elapsed frames, 1, is specified. The process stimulus method is called every frame. If wake up on elapsed frames, 2, is specified. The method is called every 2 frames. They have a set rhythm. On the other hand, if wake up on elapsed frames, 0, is specified. The method is called as soon as possible, without waiting for the end of a frame, for rendering to finish. This is done at full speed, separate from rendering. Each time the process stimulus method is executed, the local coordinate system to which the moving cube is connected is moved by 0.2 in the negative z direction. If you think this cube runner game is not so easy for you, you can specify a larger number here, such as 1 or 2, or a smaller distance here, such as minus 0.1, to reduce the speed of the moving cube. 8. In Java 3D, negative values indicate clockwise rotation. But TG is rotated by minus 3.14 radians, minus 180 degrees, around the z-axis here. So the rotation will be in the opposite direction. If the S key is pressed, TG in the C-cube object is rotated by minus math.pi divided by 32 radians around the y-axis. Similarly, positive values indicate counterclockwise rotation. But for the same reason as above, the rotation will be in the opposite direction. If the F key is pressed, TG in the C-cube object is rotated by Math.pi divided by 32 radians around the y-axis. I have already created a simpler game, Cube Slide Game. For details of how to create it, check out the following playlist. Java 3D How to create a simple cube slide game. Running the program in Eclipse. As soon as the program starts, while holding down the Alt key, press the 9 key on the numpad so that you can see the base and cubes a little bit from above. F key, S key, F key, Alt plus 9 key, S key, F key, S key, F key, S key, up arrow key. Thank you for watching my video. On my homepage, New Google Sites, I divided my how-to videos into groups so that you could find what you were looking for more easily. If you are interested in it, please visit the site. Links in description. Visit my channel to see more videos.